Hello everyone! Today we are talking about the volume and surface area of cylinders and where those formulas came from. So, to get us started, we're talking about a cylinder, which is a prism that has two circles as bases. We see cylinders all the time in soup cans, Pringles cans, big things of Lysol or Clorox wipes, our cleaning supplies, toilet paper, paper towel. Anytime that you've got those two circles as bases in that 3D shape, we are talking about a cylinder. So because circles are such a big part of our cylinder, we need to review some circle vocabulary, starting with a radius. Radius is from that center point out to any point in the circle, so it's halfway across the circle. So you can see our radius labeled over there. Now we have our diameter is going to be all the way across the circle through that same center point. All right, and you can see our diameter labeled right over there as well. The circumference then is all the way around the circle, or a fancy way to say the perimeter of a circle. So those are all going to come into play when we talk about formulas and where these formulas are coming from. So let's take a look at the formula for volume and surface area of our cylinders. All right, so you can see volume up here is volume is equal to pi r squared h, and our surface area is 2 pi r squared plus 2 pi rh. So what do all those letters and symbols mean? Starting with pi, we know that pi goes on and on forever, but we are going to use that approximation of 3.14 when we are talking about pi. For our r, we just talked about it. R stands for our radius, which is halfway across the circle. So we're going to go ahead and label that on both of these pictures. And h is going to stand for the height, which is going to be the distance between those two circular bases. So a lot of times in pictures, they like to flip our cylinders or put them at weird angles. And so it's not necessarily going to be that up and down distance every time, but it's always the distance between the two circular bases. So let's go ahead and label that on our two pictures as well. Some other little vocabulary thrown in there you might already know from previous videos or lessons, but this is going to be our 3D object, and when we take that and we unfold it, remember this is called a net. So our net of a cylinder is going to have those two circular bases, and then this outside is going to unfold into a big rectangle. So we'll talk about where that comes from here in just a second. Let's go ahead and talk about where do these two formulas come from, starting with our volume. So when we talk about the volume of any kind of prism, we take the area of the base and we multiply it times the height, and that's going to tell us how much space is inside of that or how much it will take to fill that object. So in a cylinder, our bases are going to be circles. And remember that to find the area of a circle, we take pi r squared. So really what we're doing to find the area or the volume of the cylinder is I'm taking that pi r squared, the area of the circle, and I'm multiplying it times the height so I can see how much space that would take up. And look, when you put that all together, we get our pi r squared h. So that's exactly where that formula came from. Now there's a little bit more that goes into our formula for surface area. So remember, for surface area, we're adding up the areas of all the sides. So when we take that net, remember we have these two congruent circles, so we need to find the area of both of those and add them to the area of this rectangle. And we put all those areas together, that gives us the total surface area. So as a quick reminder, remember that the area of a circle is that pi r squared, so that's what we're going to take to find the area of those. And because they're congruent, we have two of them. So that's where this 2 times pi r squared comes from. It's two of those equivalent circles. Now, the area of a rectangle we find by multiplying the length times the width. So when we take this rectangle, we want the length times the width. Now, we can see that the height is the width. That's going to be one of our sides, so that's where that h comes from. But what is this 2 pi r? So this side, actually, when you unfold that cylinder, this rectangle, the length of it is actually the distance around the circle. So you can see that if I unfolded that rectangle, it would be the same distance as this distance around the circle, which we know is called the circumference. And the circumference of a circle is 2 pi r. So that circumference, 2 pi r, which is our length times our height, gives us the area of that rectangle, and that is where that comes from. So we've got our two circles plus the area of our rectangle, and when we put that all together, that is where that crazy formula comes from. Let's put those formulas into action, and we're going to start with the substitution. So remember, when we're substituting something, we are taking something out and putting something else in to replace it, just like a substitute on a sports team or a substitute teacher in the classroom. All right, so let's talk about those two formulas again. I'm going to write them both out. And remember that both of them use R for radius and H for height. So we need to make sure that we know what those two values are. So in this cylinder, our halfway across the circle, or our radius, is going to be 3, and our height is going to be 12. So I know that I'm going to be taking out this R, and I'm plugging in 3 instead, substituting it. And I'm going to take out this H, and I'm going to plug in 12 instead. So I want to find out which formula matches that exactly. So I can see that A, this pi times 3 squared times 12, this matches my volume formula perfectly. So that is our volume. This one we can see is not quite right? We've got that 6 in there, and 3 squared is not 6, so this does not work as far as substitution goes. So now we've kind of narrowed it down for C and D to match up with our surface area formula. So looking at this, we've got our 2 pi, our radius is 3, 2 pi, radius is 3, 2 pi, radius is 3, so that is all good. And then we've got our 2 pi, R and H, which we should have our 3 and 12. We've got our 2 pi, 3 and 12. The big difference you can see is that this one is multiplying and this one is adding. And we can see in our formula, we should have that adding symbol. So for this one, our surface area, D, is the one that matches up with that substitution. All right, so we know where the formulas come from. We know how to use them with substitution. Now let's practice actually solving for volume and surface area of some cylinders that we can look at. All right, so our first one, we have, how do we calculate the volume and surface area of the cylinder? All right, so the first thing is we always need to find our radius and our height first. Now, we can see in this one, we have this 24 goes all the way across our circle. So that 24 is actually our diameter. So I want the radius halfway across that circle, and so my radius is going to be 12 because it's going to be half of that. So 24 divided by 2 gives us 12. So my radius is 12, my height is going to be that 8, and now I need to write out those formulas again. Now that I've got those written out, I'm going to use Desmos in order to solve. So again, instead of this pi, we're going to be using that 3.14. So I'm going to type in 3.14 r squared h, and then on the next line, I'm going to type in my surface area. Now, when you do 2 and 3.14 next to each other, if you don't put a multiplication sign, it looks like 23.14. So you want to make sure we're putting a times sign right here, and also a times sign or multiplication sign right there. All right, let's take a look at what that looks like in Desmos. Okay, so you can see that my volume formula is on that top line, the 3.14 r squared h, and then the second line is my surface area, the 2 times 3.14 r squared plus 2 times 3.14 rh. So now I know whatever's on the top line is going to be my volume, and whatever's on my second line is going to be my surface area. It's helpful to set up your Desmos like this when you're solving a bunch of problems, so you can really easily just change out the radius and the height and get your answers both times. So our radius we said was 12, so I'm going to type in that 12 on here, and our height we said was 8. So now when I plug that in, I get that 3617.28. That's going to be my volume, and my 1507.2 is going to be my surface area. All right, and there we go. So that is how we calculate the volume and surface area of a cylinder. Let's look at number 2 together. So this is what I was talking about. A lot of times they like to kind of twist them or turn them into different orientations. So we need to make sure we're always looking at the circle first for our radius, and this is halfway across, so this is going to be my radius of 2.5, and my height again is going to be that side connecting those two circular bases. So my height this time is going to be 7. I'm going to plug both of those into my formulas in Desmos, so go ahead, pause the video here, try it out, and then come back to check your answers. All right, check out your answers and see how you did. We should have gotten 137.38 inches cubed for volume and 149.15 inches squared for surface area. All right, one more of these before we get into our word problems. So let's take a look at this last cylinder here. Again, they tilted it over to the side and they gave us the distance all the way across. So this is our diameter, not our radius. So in order to have my radius, I need to take that 18 divided by 2, which is going to give us 9. So I've got a radius of 9, a height of 20. Pause the video here and try this one out for yourselves. Okay, go ahead and check your work and see how we did. Should have gotten 5086.8 yards cubed for volume and 1639.08 yards squared for surface area. All right, hopefully now that we're feeling comfortable with these formulas, let's take a look at some word problems. So going back to those real life situations, we've got Pringles cans, right? A Pringle can has a radius of 2 inches and a height of 10. How much wrapping paper would it take to cover the can? Again, if we are covering something, we're talking about the outside, which is our surface area. So that is the formula we are going to use. They told us that our radius is going to be 2 and our height is going to be 10. So pause here, get your answer, and come back to check your work. Hopefully we got 150.72 inches squared. Next up, and last one for this video, we have Luca filled the jar below with strawberry jam. How much jam did he have in total? So again, if we're talking about how much it's taking to fill this up, we are talking about volume this time. And we want to pay attention that they're giving us the diameter all the way across and not the radius. So when I cut this 3.2 in half, I get that my radius is 1.6 inches. So I've got my R equals 1.6. My height is 5.2. You know the drill. Pause the video here. Come back to check your work. And when we plug that in, we should get 41.8 inches cubed. So hopefully we are feeling comfortable with volume and surface area of cylinders. We know where the formulas came from. We know how to use them. I hope you learned some good strategies today. Have a great day, and I'll see you next time.